Okay, so let's see what goes on with sine and cosine ratios when we use complementary angles. Okay, fish, swim away. Okay, come on, fish. Clear the screen. Okay, ooh, we even have an octopus, an eel, oh, and a strip of bacon, yeah. All right, and the scuba diving cow. Of course, the clownfish would be the last one to get out of the way. Silly clown. Okay, so what are we looking at here? Again, my usual quick reminder, SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, right? SOHCAHTOA. Okay, now, previous lesson, I very quickly said, hey, you noticed something? And then I just ran right on by, but you should say, oh, I noticed something, right? This triangle, of course, has a sum of 180 degrees, which means the measure of angle R plus the measure of angle S has to be 90 degrees. In other words, those are complementary angles. Right? Angle R and angle S are complementary angles. And look at this. The sine of angle S got us the same result as the cosine of angle R. The cosine of angle S got us the same result as the sine of angle R. So what's going on? Well, the sine and cosine have complementary angles. Okay, so here we go. The sine of angle A has to be the same as cosine of angle B. Sine of angle B has to be the same as cosine of angle A. Cosine of angle A has to be the same as sine of angle B. Cosine of angle B has to be the same as sine. Cosine of angle B has to be the same as sine of angle A. Yeah, got tongue-tied there. Right? It's always just a complementary, right? 90 degrees minus one angle gets you the other angle. And for one side, opposite, switches and adjacent switches when we go from angle to angle. So let's check and see if this really works. Let's see if the sine of 30 degrees really is the same as the cosine of 60 degrees. All right, what do you have today for us, Mr. Bob Ross? How did they get the cow to stand still that long for that portrait to get painted? I don't know. Must have been a very, very, very patient cow. Hey, 30 and 60, we are in luck. Right? 30, 60, 90 triangle. 1 is the short leg. Double it. 2 is the hypotenuse. Or multiply the short leg by root 3 and you get the longer leg. So sine of 30 degrees, opposite over hypotenuse, 1/2. Cosine of 60 degrees, adjacent over hypotenuse, 1/2. Yay, they are the same. All right, so let's try rewrite in terms of cosine. If I've got the sine of 50 degrees, what is that? Oh, it's the same as the cosine of 50 degrees. How come? Well, 90 minus 40 is 50. What if I want the sine of 73 degrees? What is that in terms of cosine? Well, 17. Right? Ooh, let's go the opposite direction. What if we start out with cosine? Cosine of 27 degrees. That would be the same as the sine of 63 degrees. Right? 90 degrees, subtract 27 degrees is 63 degrees. Well, I'm thinking what, 48 plus 42 is 90. So if 48 plus 42 is 90, I must need the sine of 42 degrees. Okay, so we got a pretty straightforward concept here, but IXL, what I'm going to have you do here, we don't want to leave radical denominators, right? IXL is going to be demanding of exact answers today. So let's pretend I've got tangent of 30 degrees, right? That could be one of the questions on IXL. Well, if I'm at a 30-degree angle, opposite over adjacent is going to be 1 over square root of 3. Can't leave square root in the denominator, right? So I got to multiply by the number 1, but the number 1 is going to be in disguise as root 3 over root 3. Upstairs, 1 times root 3 is root 3. Downstairs, root 3 times root 3 is the square root of 9, also known as plain old 3. So there is an exact answer. That is what would need to be typed in to IXL today. So if they give you the tangent of 30 degrees, the answer is root 3 over 3. Now, there are no pictures on IXL today. All right? So they're just going to say tangent of 30 degrees. There will not be a picture to look at. So you need to have these triangles available. Now, that doesn't mean you have to have this PowerPoint up, or you don't have to be staring at this slide of the PowerPoint. But you need those two triangles somewhere in your vision. So I don't copy them down on a piece of paper in your own handwriting, or however you want to do it. You need to be able to refer to those triangles, because an IXL is just going to say tangent of 30 degrees. There won't be any picture. More about IXL. Right? We normally just study sine, cosine, and tangent in geometry. That's only half of the story. But we normally save the cosecant, secant, and cotangent for second year algebra. IXL must think we're like superstars. I don't know. So you'll go through IXL, and at some point in time, instead of sine, cosine, and tangent, they're going to start asking about cosecant, secant, and cotangent. Just stop, right? When they start to do that, please just stop, right? I've done this, and I get a score of around 72. You might hit there a little bit earlier, a little bit later, but somewhere around there, they start asking about the other trig ratios, and we are not going to do them in geometry. Those are for a different time. So, actually, it's not a painting, it's a line drawing, a sketch. Pencil or charcoal. That was one patient cow that they had stand there like that. All right, so you got a worksheet and you got some IXL to take care of.